Welcome to the knowledge series. Under the course EC407 Computer Communication, we are going to discuss in the area related to the transport layer, UDP and TCP. So, what is UDP and what exactly the TCP it indicates? So, as you all know that when you want to download any file or you want to send any email, so you directly send from your systems to the next destination user. So thereby you try to maintain a connectivity between the sender and the receiver. So UDP does the same activities. UDP stands for User Datagram Protocols. It is a transport layer protocol and it is a part of a internet protocol suite. That's why it is referred as UDP/IP. And this particular protocol, it is a unreliable and a connectionless protocol, so that it can offer a process-to-process delivery with a limited error checking. As you know that in the case of UDP, the connectionless protocol as it is maintaining, so it will not establish any sessions. Sessions means we know that whenever two devices, say a sender and a receiver, need to communicate, so there should be a dialogue or a handshaking, like a request, clear to send, data, acknowledge. So these sessions UDP does not establish. Thereby it tries to send the data, and it happens that when the sender sends the data, even if the sender hopes that data is reaching at the destinations, there are chances that data may get lost in the medium itself, or in the intermediate point itself, or even if the data is sent, the full data is not being received at the receiver side. So the receiver will not able to see the appropriate data that the sender tries to send. So what happened? The UDP will not able to guarantee about the delivery of this data. That's why this UDP is considered as a simple protocol or considered as a powerless due to unreliable transport. So here the connectionless, what exactly means is that the segment that is being sent from the packet that is being sent from the sender side to the destination host, there will not be any prior establishment of the path, and since the prior establishment of the path is not there, the connections is being considered between the sender, the host and the terminal is a unreliable, or there is not any guarantee about the transmissions. So in the case of a unreliable, the UDP does not perform any error and flow control. As you have studied or you might have seen my previous video series about the error and flow control, there I have mentioned how that error, if it occurs in the transmission, how that error and the flow control has to be properly maintained. So that is not been maintained in the case of a UDP. So the segment that is being sent, so there is no numbering in that case. So whatever the segment it is sent, it has either it may be received by the receiver or it may be lost by the receiver. Thereby UDP will not take any further risk. Hence the UDP is also known as file and forget for protocols. That means file means sending, and after that it is forgetting what is the status of that file. and it sends the data and it does not care about it. So if you see the characteristics, one is connectionless, another is unreliable. Based on this one, you will find that there is no much overhead problem in this case of UDP, and thereby the UDP basically useful and for the real-time services like computer game, audio and video communications, for a conference, live conference. All these applications the UDP need to transport. Moreover, in case if there is a loss of a packet is there in the video or in the voice traffic, normally it is goes unnoticed because of the small packet loss, and thereby the UDP still can able to process with the remaining packets, even if it is a little delayed also. So there is no particular checking of the errors, and thereby it saves the bandwidth. Saves the bandwidth means there will not be a retransmission of that error data. So that's why UDP is considered to be more efficient in terms of a latency and in terms of a bandwidth, because of the factors like it does not have any sessions. Now we go to the next sections with respect to the UDP features. Now, as you see that in the case of a UDP, it is a connectionless oriented protocols. That means you are not maintaining a connections between the sender and the receiver prior to sending a data. It is only that UDP will directly see the network and it will be able to see the send the data. It will not see whether the network is having a traffic congestions or not, or the network bandwidth is low or not, but still then it will try to sense the data. It does not provide congestion control mechanism. That means it does not see the traffic blocks. Traffic blocks means data blocks in the case of a UDP. It does not guarantee the order deliver of the data. That means from the UDP sender from the sender terminal under the UDP, if the set of segment is being transferred or the packet is being transferred, it does not guarantee whether it is reaching to that destination in a proper order or not, like a 1, 2, 3 in that order or not. The UDP is a good protocol for data flowing in a one direction. That's why, since the data is flowing in a one direction, not moving through n different locations, so it assumes that there is a guaranteed order delivery of that particular data. It is a simple and suitable for query based communications. That means first of all, it is a simple protocols because a powerless and unreliable transport is there, and moreover for a query based communications where you do not have much handshakings conditions. So because of the lesser handshaking conditions, the UDP find it suitable for the query based communications. The another point is that UDP is used when acknowledgement of data does not hold any significance. That is what we try to see in this particular protocol, is that in these protocols there is no acknowledgement or a handshaking exist in this particular scenario, and because there is no sessions, that's why UDP find it more reliable and connections less oriented protocols. UDP is a suitable protocol for streaming applications such as voice over IP, multimedia streaming, conferences, as I have noted earlier. Now let us see the pattern how the UDP is sending the packets. The UDP is consisting of data, UDP data, UDP header, and a IPv4 header, the protocol of the network. So if a data need to send, automatically this data which has been coming from the application layer towards the transport layer, of course if I am taking a TCP IP protocol, so automatically in the transport layer the UDP header is being added, the encapsulated, and along with that UDP header encapsulations, the IPv4 header is already there because of the network. So this IPv4 datagram, when you try to see across this one, the UDP header format is shown. So UDP header is basically a 8-byte. You can see over here it is a 8-byte fixed and a simple header, and the 8-byte header carries the informations. That is what it has been, you can see across this one as a data. So when you say when you talk about a UDP header, automatically you have to understand that header 8-byte is nothing but 8 into 8, 64. So which has been divided here 1, 2, 3, 4, 16, 16, 16, 16. So that 64 distribution you can see on the source port, destination port, length port, and checksum. So these port number are 16-bit long, and this ranges from 0 to 16. Where port 0, it is always reserved, and based on this port number, the user try to request or process the informations. Now let us see the source data. The source data is basically a 2-byte long field, and this identifies the port number of the source packets. That means the packet source from where this particular packet is being moved, so that port number is being assigned with respect to this source port. Destination port, it is also a 2-byte long field, and it is to identify the port of a destination packet. So just like here it is a source packet port, it has been shown, the destinations were a port also. That means from where it is starting, where it is reaching, so that port number is there. You can assume like you are leaving your house and you are reaching to the college main gate. So that is a port. That is your house gate is also a port, and college gate is also another port. So like that you can assume. The length of the UDP includes the header and the data. So it is basically a 16-bit field. Checksum is a 2-byte long, and this is used for complementing the sum in the case in the UDP header, because you are generating a checksum before transmitting, is that you try to do a complement of the final sum, and that complemented value along with the data you are transmitting, and at the end side you add that value with the entire data, and then you do a complement, then it has to treat as 0, 0, 0, 0. Like that, if you are getting a value, that it is indicating that there is no error existing in the transmitted data. So this is what being considered in the case of a checksum field, that will define whether all the set bit is equal to 0 after verifying the checksum values. So this is what we see in the case of a UDP header. So whenever data is sent, UDP header will have these formats. That means you can see in this box these things are coming. So here everything will be there, and based on that this data is being transmitted from the sender to the receiver side. Now we see the application. Now one more point, as I was pointing out in this case of a UDP header, here this is in the case of a UDP, this checksum is not mandatory because there is no error control and flow control is being provided in the UDP. Hence, UDP depends based on the internet protocol and based on the internet control message protocols for the error reporting, rather than using the sessional methods of or a handshaking methods to verify the errors or the flow controls. So this is for your informations. Now when you see the applications, there are several applications with respect to UDP. So one of the application here, it is being shown as a domain name service. So that is a DNS. So as the domain name services, it is basically used to identify the entry of the TCP IP protocols that uses the IPs. So if you are using for the server case, so server case UDP you are using, stream media you are using the UDP. If it is a internet voice over IP, you are using a UDP. So all this area you need IP address. So this UDP under this particular application supports this DNS systems or a DNS hierarchical systems. Another is simple network management protocols. When we that is how the network management is being handled using a UDP. And basically network management is for monitoring the network and its components. So UDP's applications supports this particular scenario about the network management protocols, that is your SNMP. So the SNMP protocols is basically manages the hubs, servers, router, bridge, so so that through which the data passes. So UDP its application is supporting to SNMP. Another is file transfer protocols. UDP supports these file transfer protocols because whatever the files it need to be processed, it is being use the UDP IP protocols from the host to the sender. So there the data flow is, of course data flow is not being monitored, but it needs a port so that whatever the port is being used for the sending a data under the UDP, and the receiver should have the similar port on the other side to receive it. So the FTP, that is a file transfer protocols, is basically built between the client and server architecture of the UDP. Routing information protocol, how the routers is being linked so that the UDP connectivity can able to pass the informations through this router to the appropriate destination through various router. Kerberos, with respect to the security aspects, the UDP try to protect its own data. That is with respect to the Kerberos protocols. Another is multicasting. UDP can able to supports the multicasting mode of communications. So these are nothing but the various applications related to the UDP with respect to the use of a network and its applications related protocols. Now we go to the next discussions about the transmission control protocols. As you can see here in this particular figure, there is a two system is there, and the two system is communicating in such a way that a system is connected to a internet systems. Assume like this is a systems, it is a server which is giving a network connectivity or the internet connectivity to these systems. and you want to download a file, or you want to view a files, or you want to send an email to the to your friend on the other systems. All these things is possible only when there is a proper a way of downloading, or a proper connectivity exists between the sender and the receiver. So the communication between the two computers need to be good and reliable to guarantee that the data is received correctly. That means whatever the data is being sending from the sender to receiver, or the receiver to back to the sender, there should be intact in that particular data. There should be nothing should be missing in the content of the data. And if the data is complete and without any loss, so we treat that particular web page as a good. So that means downloading is completed fully. If the downloading is interrupted, then the data, as you have observed, your data gets corrupted. So you will try for a further downloading or further resending of the data. This is what we see in the case of a transmission control protocols. Now, in the case of a transmission control protocol, one of the important it is one of the important protocol of the internet protocol suite, and mostly it is used for the data transmission and in a communication network. This particular protocols actually is a connection oriented protocol. As you have seen in the UDP, it is a connectionless protocol, whereas it is a connection oriented protocols that offers a process to process reliable delivery. See, whenever you say a process to process, then you have to understand that in this particular scenario we are going to use a port address. So the connection oriented protocols, when we term in the case of a TCP, that means it tries to create a virtual connections, and thereby it tries to establish the link between the sender and the receiver, that means host and the terminals, and after that it will send the data. And once the data is completely transmitted, or data is received, downloaded completely, the connection is released. Reliable means that TCP always provide a error and flow control, as I have stated in the case of a UDP, which is not performing this particular area. In the case of a TCP, it provides error and flow control, and thus it ensures that there is a delivery of this particular segment to the destination. That means here in the TCP also, the data coming from the applications layer in the that is converted, that is put down into a segment form, and each segment is transmitted with its header from the sender to the receiver. And when the data is not received at the receiver, automatically based on the acknowledgement, whether it is a positive acknowledgement or a negative acknowledgement, the TCP will do the necessary steps. So the stream of data which is coming from the application, it is put into segment, and thereby it communicates from the source to the destination's terminal. Thereby the acknowledgement for that segment or the every segment is been assessed by the sender, and thereby it decides whether to retransmit or not. Now let us see the another figure. If you are performing a TCP, it is a connection oriented, and it is when you say connection oriented, that means it is having a sessional. That means based on the sessional and based on the connections oriented protocol, it tries to communicate between the sender and receiver. So if the TCP exists, TCP protocol is followed, then you will see that there will be a proper download will be there. That what you can see There is no interruption is there from the initial point to the end point. But when you have a without TCP, you have a breaks in the downloading, and whenever you have a breaks, it will create a error. This is it will show as a file incomplete. So this is what we see in the case of a without TCP scenario. So now this if this scenario exists in the UDP, you will understand that the UDP will try to ignore it, and assuming that that packet is received at the receiver side, and UDP continues. That's why in the case of a UDP, it does not focus on the reliabilities. Now, when we talk about, when you speak about the sessions, you have to understand that the session is basically is performing because of the connection-oriented protocols. That means that it must receive and acknowledge under the sessions between the two system host and the terminal, which is doing a communications, or which is used for communicating each other. So if two computers makes a connections using these particular sessions, then you can see that there are three type of sessions here. One is acknowledge, another is one is from the sender sends the sync, that is sender sends initially send the sync to the receiver. Receiver, after receiving it, it sends the acknowledgement for that sessions back to the sender. Sender will receive after receiving, it will find that okay, the sync which was sent by sender, it is the one which the receiver has received, and it has the system has acknowledged. Then the systems will try to, sender will send the data, and thereby you can see the sender will acknowledge the receiver and ensure that there is a connectivity exists between these two systems. After doing this three stages of handshaking, or the three stages of sessions, then the data will flow. So once the data is sent from sender to receiver, then the next is that acknowledgement, and those things we have discussed earlier also. So this is what we see between the TCP, is that how the sender send, and when the receiver receives, what the receiver does. So once this particular session is taken place, the data will be transferred, and this shows that TCP guarantees the data delivery, and if it is missing, it will try to resend that particular data once again. So this this gives an idea how the TCP maintain the connection-oriented conditions as well as reliability conditions when compared to the UDP. Now let us see some other areas like TCP services. So when we try to see that TCP services, it does a process-to-process communication. What I have told is that process-to-process communication is definitely, it gives an idea that it is a transport layer protocols. It does a stream delivery service. If you have a stream delivery, that means unlike the UDP perform the TCP also perform the stream-oriented protocols, and it sends the stream of bytes, and thereby the receiver will consume the stream of bytes. Next is the sending and the receiving buffers. That means because of sending and the receiving buffers, the stream of the bytes, it will store in the buffer, and so based on the buffer storage on the sending side and the receiving side, it will try to controls the flow and error. So that's how the TCP try to implement the error and flow control, so that there will not be any congestions. Next is a segment. because at the transport layer the TCP groups the number of bytes into a packet called the segments. So TCP adds the header to each of these segments, as you have seen in the case of a UDP, and deliver that segment to the IP for a transmission. So there will be a numbering will be there for the segment, and if the segment is not received or out of order or lost or corrupted, then it is resent. So all this stage is handled by the TCP with the receivers receiving process awareness. So thereby the communications between the sender and receiver can be considered as reliable. TCP services also address for the full duplex, because it offers a full duplex service in which data can flow in the either directions, both direction at the same time. And each TCP has the sending and receiving buffers. That's why the segment can move in the both directions. Reliable services. TCP also supports the reliable transport protocols, and it uses the acknowledgement mechanisms to check the safe and sound arrival of the data. So that is what we try to see in the case of reliable services or the TCP reliable transport protocols between the sender and the receivers. So this is what we see with respect to the TCP services. Now let us see the TCP features. As you know that just like in the case of a UDP, which is a connectionless, TCP it is a connection oriented protocol. It tries to maintain the reliability of that particular protocols. Between when I say reliable, means it is the control on the error and flow. TCP ensures that the data reaches to the intended receiver to which it is assigned that packet. TCP provides error checking and recovery mechanisms. So this is error checking and recovery mechanism used based on the buffers. TCP provides end-to-end communications between the source and the destinations. TCP provides a flow control and quality of service. So flow control and the quality of services, when we use the terminology on the quality of the service, means how the particular network is going to carry out the proper mechanisms, so that there will be a proper schedulings will be there. Schedule means proper methods by which the packet will be sending. If the packet is there in the buffer, how the particular queue it will be maintaining. So all this thing is a factor related to the quality of service. How the bandwidth is being used. Is there any jitter? Jitter is there in the, or the variation in the packets is there, or the packet or the packet can when it is sent from the sender to receiver, is there any delay? So the is there any reliability? All these factors is a part of a quality of service. Flow control I have already stated is that error checking and recovery mechanism, flow control, all this thing is related to the buffers as conditions. Error checking is also one conditions between the with respect to the acknowledgement. Also you can try to see error checking and recovery mechanism. You can take it with respect to the acknowledgement, this one with respect to the buffer, and this one with respect to the characteristics. Operate the client and server with a point-to-point modes, because it is a connection oriented. One router to the next router to the next router. Already that link is being established, and then all it is sent. You know that when it from one station to the next station, when the train need to move, the station must give a clearance between the two stations, that one station the sender will send, I am ready to send the receiver, the next station will be saying that the line is free, you can send the train. So that's how the connection is oriented, and no other interferences will be there in between. thereby there will be a proper flow. It provides a full duplex server. So when we talk about a full duplex server, as you know that it can perform both it can perform the role both as a receiver and as well as a sender. So this is what we see in the case of a TCP IP protocols. Now let us see the next as a TCP header. When we try to see the TCP header, the TCP header is having a minimum of 20 bytes and a maximum of 60 bytes. So that is what we try to see the size of these particular protocols. So that is 20 bytes. You can try to see this one. That is what 20 bytes, and it can go up to 60 bytes long. So here there are different functional components in the case of a TCP header. So you can understand the TCP, just like in the case of UDP header, you are having a UDP header, on this side data, on that front side IPv4 header. So when we take a UDP header, there I have shown how the 8 byte is being represented. So in the same way here we try to see the 20 byte to 60 byte how it is being shown. So one is the source port. This is the source port of the application process on the sending device. This is the destination port of the application process on the receiving device. So this is sending device, receiving device. Sequence number, because it's a 32 bit and it is used to put the data back in a correct order. So that's why a sequence number is being created, and this sequence number is being given to the each segments. So that's or the packets, thereby the packet will be receiving in a proper order. Acknowledgement pin, so which is nothing but which is a 32 bit, and it is a flag that contains the sequence number, so that the data byte after receiving it, it has to acknowledgement for that previous data that has been sent and which was received. The next is a header length. Header length is nothing but the size of the header that is being used for this TCP. It is a 4-bit field, and that is that defines the TCP header of the data from where to where it has to move. And the 3-bit is this code bit. Sorry, this 3-bit here it is being reserved in this case for the future use. And this code bit it's a flag. So this particular flag, it has consisting of acknowledgement, RST, sync, NS, like that. Different components are there in the flag. Different type of flag is being used. Flag is indicating a state of that particular systems. The window size, so it's a 16-bit which is the window size for sending and to the receiving host, so that what is the size of the data that the sender can send and that the receiver can expect. So that is what mean the window. Checksum is nothing but it is consist of a header data and pseudo header for data integrity or checking the data under the TCP segments. So this is a options of a 32-bit field, and in case if the data is less than 32 bit, and this is used for doing a padding. So padding with the remaining bits, so that it can reach up to 32-bit boundary. So this is an options, and this is the data. So you can see the data bits offset, and this is connected to the TCP header. So this how the TCP header is going to defines the size of the size of the TCP header for the packet movement or the segment or you can say the segment from the source to the destinations. Now coming to the applications, let us see the application of a TCP IP. There are different applications, as I have stated in the case of a UDP, that is a simple mail transfer protocols. It used to help for sending a mail from one system to another system. File transfer protocol, that is FTP, it is used for sending a large files from the source to destination. Dynamic host configuration protocol, that is DHCP, it is assigning for the IP address. Telnet is basically a bidirectional text communications via a terminal. Hypertext transfer protocol, it is used for how to transfer the information through the web pages. Web pages is nothing but www. Domains name service, that is a DNS, it translates the website name to a IP address, that is what a DNS. Simple network time protocol, that is SNTP, it provides the time of a day of a network device. So this is a network time protocols. So that is the time of the day for the network devices. That is the SNTP protocols that is being followed in the case of TCP IP protocols. So as you can see, just like a UDP, the TCP also follow the similar type of protocols, of course more or less same supporting. Of course the applications, when we try to look across the application of a TCP IP as compared to the UDP, of course you will find that basically TCP will be focusing more on the file transfer email services rather than for the streaming multimedia, but there also the TCP is also playing a equal role. Now coming to the what are the benefits of TCP IP protocols, that's what we will try to see in this scenario. Now when we try to see the TCP IP benefits, it is basically supporting the industry's standards. It can be interoperable, means you can use it for the UDP scenario and TCP. Open conventional suite, that is if you are you can support for the internal and as well as for the external entities to use that same networking applications. Versatile for a client server engineering. If you can use for the LAN, MAN, WAN, IP address to each computer on the organized. That means TCP IP will be able to support for the number of IP address which is associated to the systems. Challenges in this case is that not a generic in nature. Generic in nature mean it indicates that in this particular protocols, just like the UDP scenario, you will have a protocol stack issues because in the case of TCP, suppose if you want to look for a Bluetooth connections, so that is not being supporting. So that is what we see in the case of a TCP IP protocols, and not clearly isolates. That means the concept of service interfacing and protocols used with the modern systems is not clearly portrayed. Another is that it does not recognize the data link and the physical layers, and this is in exceptional cases. This functionality between for the accessing a data link and the physical layers issues is one of the challenges in the case of a TCP IP with respect to the modern systems. information interface layer for the transmissions is also one transmission scenario is also one of the issues, and not guaranteed deliver under the transport layer. There are certain cases is that the packet delivery of the packet the TCP will not able to guarantees. So that is also one of the challenges we can try to see. However, whether if you see the challenges, still then looking into the benefits aspects, most of the challenges with respect to the modern systems, it will try to resolve it in the future with respect to its advancement in the upgradation of the systems and its protocol configurations. Now let's see the next phase of our discussions with respect to the what is the difference between the TCP IP and UDP IP protocols with respect to communications. Now if you try to see the TCP IP and the UDP IP communications with respect to the handshake, TCP has the sessions like sync acknowledge. So based on first it will send a sync, then it receives the acknowledgement, and finally it builds the connections acknowledgement, and thereby the data will transmit. Whereas in this case, if a request is there, it will respond, and it will keep on. If a receiver is requesting to sender that I want a data, then it will keep on sending the data. So that is what we try to see in the case of a UDP. So this is a connectionless and this is a connection oriented protocol. Let us see in terms of TCP IP distinguish. If you take a protocol, this is not the transmission connection oriented protocols. Another is a use a datagram protocols. So the protocol conditions, what we see that transmission control protocol and use a datagram protocols. So that is the first one. Connection. This is a connection oriented, this is a connectionless oriented protocol. Usage. When you try to see the usage is that since it maintain a connections, so there is a high reliability with respect to the packet transfer, and if any loss is there, it will retransmit. So this is a little slow, whereas this is not reliable because this is fast and efficient transmission with a small queries and a huge number of clients. That's what it tries to say. It is not. It is not a reliable, but it is supporting for a audio and video application. Ordering of a data packet, rearrange the packet in order, whereas here it is not a arrangement of the packet is not in order. It is not an inherent characteristics. Reliability, you try to say it delivers the packet with acknowledgement. It does not do a delivery with acknowledgement. After the streaming of the data, so here error checking and recovery is there. Here it is a simple error checking and no error recovery is there. Overhead in this case is low, but higher than UDP. But in the UDP it is very low, the overhead. Transmission speed, if you try to take in the case is it is lesser as compared to the UDP. This is very high transmission speed. And if you try to see the acknowledgement, it acknowledges the segments. Here there is no acknowledgement. And if you look about the size of the data it is transmitting, here a very large data it can transmit. Here only smaller data can able to or a moderate amount of data can able to process at each time. If you look across the examples of a program and service with respect to the TCP, here HTTP, HTTPS, FTP and many computer games are followed is being used supporting for this TCP, whereas under the UDP protocol it supports the DNS, IP telephone, computer game, RIP, SNMP, conference video. So all these things is possible under the case of a UDP. So finally we come to the conclusions of this TCP and UDP protocol is that we find that the TCP is a connection oriented protocols and UDP is a connectionless protocols. However, we find that both these protocols are plays a major role. UDP supports for fast and efficient applications. However, TCP is also equally giving the similar support, but not up to the UDP. But in the most of the internet protocols, the TCP plays a very major roles and more amount of a contribution the TCP IP protocols does as compared to the UDP IP protocols. So with this we conclude.